All right, welcome everybody to the EES meet and greet. Really excited that you took the time and this opportunity to get to know the department a little bit better. Most of the time is going to be devoted to chatting with you and getting to know each other. But I did want to start off by giving a brief overview about the department and what we have at Temple in the areas of earth and environmental science. So we'll talk a little bit about major themes and what it is that we do here and how we do our work at Temple. And then what comes after in terms of career development and preparation. So at Temple, one of our major foci is thinking about earth and environmental science and the fact that we're operating at a very large research one institution, but that we have a very small, tight-knit community focused on earth and environmental science. As a large institution, we actually have advanced resources. We have advanced computing resources, departments fully devoted to computer science and other areas of physics, astronomy, chemistry, biology, mathematics, and computer science. But we also have resources like in the Tyler School that looks at sustainable architecture, or in the in GUS, Geography and Urban Studies, that looks at the interface between social justice and urban planning and sustainable environments. We can draw on all of those issues together, but in our department, we focus on the science piece of that. And then students are then able to reach out to all these issues to help build their specific careers. We offer an opportunity to use the science you want and to engage in it in a way that you're interested in. One of the amazing things about earth science is that it's a very applied science that gets to reach out to all these different pieces. And it allows you to work in a lab if your focus is on lab type work. If you want to do field work, we do field work and we offer field trips. If you want to synthesize data with the vast array of community data sets or remote sensing from satellites, we can help you understand how to do that. We offer courses in each of those things, as well as potential research opportunities in those various areas. If you can ask it, we can investigate it, test it, we can talk about how to apply it and make it a sustainable future for the earth through the instruction that we offer in our department. And again, we are this small community inside the extensive resources of a large R1 institution. The department is structured so that we have two major undergraduate programs. We have a physical sciences program, a geology program or geoscience program, and we have an environmental science program. I'm the chair of the department that oversees both programs. My focus is on the structure of faults, fault mechanics, and geothermal energy. That's me there on the left. On the right is Sujith Ravi, who focuses on ecohydrology, landscape evolution, and land-water energy, the land-water energy nexus. But we also have a variety of professors who look at various different aspects, including Ilya Boinovich, focused on coastal processes and hazards, Steve Shemtob on geochemistry, Alexandra Devatsis on planetary geology, as well as interfacing with the community, David Grandstaff also in geochemistry, Bojan Kim on how nanominerals move through the environment, Atsuhiro Muto on glaciology and geophysics, particularly working in Antarctica, Jonathan Nyquist on environmental geophysics, Dennis Terry, who's here with us tonight, working on soils and paleosols, Laura Turan on hydrology, and Allison Tamarkin-Daratsian, also here tonight, who focuses on paleontology. In addition to all the collaborations we have, say in the Department of Biology, that our environmental science program actually shares with bio. We also offer, to help students progress through the program, direct advising within the department, and that's headed up by Allison, as well as Ilya Boinovich and David Grandstaff. And they offer sort of career-specific advice about how to choose your courses, how to organize your schedule, and how to make connections within the department. So you don't just get general CST advising, you actually get a direct member of the department who does the science you're interested in, who helps you develop your career and educational program. I'm also excited to reveal that we have recently updated our environmental science degree to offer concentrations that allow you to specialize your focus within the environmental science area. There are 4 different concentrations that are structured to help you develop that focus. And then there are electives within those concentrations so you can really specialize in the way that you want. There is a climate-focused concentration, an applied ecology concentration, and an environmental geochemistry concentration, and a hydrology concentration. All of these offer you new opportunities and avenues for developing your specific interests and careers. Our department is small. We get to know each other. EES faculty have won numerous teaching awards. We're particularly actually known for the quality of our teaching and mentoring and the degree to which we interact with students. In general, we have some communal areas that we spend time in, as you see in the picture, and we get to know each other and people hang out and work together. In addition to that, we have peer mentoring programs so that we can pair new students with more advanced undergraduates to get feedback about how to progress through the department. And there's also an Owl to Owl program that will pair any interested undergraduate with an alumna in their field to talk about career development through someone who's actually out doing the work. And we offer extensive research experiences at a variety of different scales. We often start you out by putting you in contact with a graduate student so that you can shadow them in their work and support that. But then you can also volunteer to work in a lab. Often that connection is made just by coming in and starting a conversation or an email, or it grows out of a course that you've had with a professor. And we've been very successful at turning that either into independent studies or undergraduate research projects that culminate in published presentations at scientific meetings or within opportunities in the college. So, you know, these different ways of developing your career and becoming in contact with people who are practicing the science is really important. So if you get to shadow a graduate student, you get to see someone in that next step and also get that student's perspective about how they started and how their undergraduate career is going and culminated in a graduate career. You can volunteer to work in the lab, which is on your own time and is a very common first step to establishing, so you can test out different interests with different faculty. Or you can take an independent study for credit so that it shows up on your transcript. And then there's the formal, as I alluded to earlier, undergraduate research program that's run by the College of Science and Technology that actually provides financial support for doing research in conjunction with the faculty for qualified undergraduates. The Temple University Symposium for undergraduate research is another way you can display and practice your craft and how to communicate your results. But in our department, not only do we have students participate in that, it's very common for students to publish abstracts at national meetings, as you see in the image here below, as well as potentially full papers or contribute to full papers. In terms of additional professional development, the research and mentoring with graduate students and faculty is the key elements. But there is an SEG Honor Society that actually involves workshops and other activities based around career development specific to earth science. We've been running occasionally EES career nights that put you in contact with recent alumni so you can see what that next step in your career can look like and talk to them about their experiences. And then there's the more general and inclusive CST job fairs that are run with additional professional developments. Those emails come in and offer opportunities for work. We also manage a jobs opportunity website that's only available to current and recent undergraduates through your Temple University login. So anything that comes across my desk that's a job opportunity, we push back out to students. And we've designed a specific certificate that provides excellent training for environmental science careers, especially in the greater region, giving you coursework that's specific to developing that career. Students have had a lot of success coming out of our program. You see them in a variety of different activities here. We place students in environmental consulting in the energy industry. We've placed students in national laboratories as well as research centers. They've been involved in building sustainable and resilient communities, both on the East and West coasts. And we've also placed students in state and federal geological surveys, as well as in primary and university education with faculty teaching at other universities now, with students teaching as faculty at other universities now. And many of our students do go on to advanced careers or advanced degree programs in different universities across the United States and abroad to gain a higher degree beyond their undergraduate degree. The American Geoscience Institute, I think it's worth pointing out, has conducted regular market studies, and they have repeatedly shown that the number of jobs created in the general field of earth and environmental science significantly outpaces the number of graduates coming out of university programs. And that may be even more true now given the demographic trends. So I think it's a great time to be an earth scientist and to think forward to having real excellent opportunities for job placement right out of college. And not too long ago, Forbes ran an interesting article about whether or not geology students are the happiest on college campuses. And when they speak about geology, they're speaking broadly about students in the earth sciences. And I think this is generally true. We have a very happy and cohesive undergraduate group that's common to our particular field and specific to our environment here at Temple. I'd like to take the last moment here to bring up a video that we put together a few years ago, led by Laura Turan, that talks a little bit about applying earth science in urban settings, where the concentration of people offer particular opportunities, particular problems to address that you might that might be relevant to your interests. There it is.
The bottom line, geosciences are important because we were given one planet to live on. We haven't figured out how to live on any other one. We need to understand what we're living on and how we affect it.
In this experiment, we are growing cilantro plants. We are applying silica nanoparticles directly onto the leaves of the plants in order to see if the silica boosts the cilantro's defense mechanisms and enhances nutrient uptake and plant growth. Under the scanning electron microscope, you can zoom in and actually see if there are any silica particles that are adhering onto the surface of the plant. Being able to conduct research as an undergrad is supremely helpful when actually looking for jobs or internships.
We made a map of Temple University and we mapped out the locations of like the blue emergency phones.
And then created a radius around them to see if there were any gaps. Just seeing everything through the GIS side of it, well, it's a lot more applicable to the average person who isn't a geologist.
This data can be uploaded online or it can be shared within different companies.
This is a hydrogeology lab. Dr. Turan primarily works with urban watershed areas. I got brought in to initially help with one of her graduate students. We went out and collected samples over the summer. And since then, I've been helping her do like the analysis and filtering samples and assisting her to get her paper together, which turned into my own research project.
I am a geologist at an environmental consulting company called Arcadis.
I am a hydrologic technician for the United States Geological Survey.
I work at Duffield Associates. It is a smaller engineering and environmental consulting company.
I do so much stuff that I never thought I'd do as a scientist. I have to use chainsaws. I cut up trees that are interfering with our equipment. I climb trees to put a solar panel 50 feet up in the air.
Sometimes I do some field work in more urban areas. Sometimes I am in the middle of brush and trees trying to find where I'm supposed to be taking my sample.
Not just rocks are cool. I mean, I like chemistry, I like physics. I use all of those in my job. Here I am 4 years later, and every day I learn something new.
If there's an opportunity, say yes. Every project that comes down to that someone offers me, I say yes. You never know which of those things is going to become your job.
The latest climate report tells us that we have about 12 years to get it together and fight climate change if we want to survive, basically. The urban setting makes you expect the unexpected. The environment is very natural, so it's just how it works. But then as soon as you introduce the human component, you don't really know what's going to happen sometimes. Environmental science is a really important major. We have a lot of important takeaways that you can apply to the real world.
All right, and I'll place that the link to that video in case you're interested into the chat. Now, what I'd like to do is I'd like to sort of transition out of this talking at you mode and into more of a discussion mode where we can address some of your interesting questions. And to do that transition, I'd like to start out by having the rest of the panel present today introduce themselves. And then if you're at all comfortable, it would be wonderful if each of you who are participating and considering Temple as an opportunity, introduce yourselves and share with us some of the interests that you have in earth science. So Allison, would you like to start us off?
Sure. So I'm Dr. Allison Tamarkin-Duratsian. All my students call me Dr. Allison or Dr. A because my last name is way too long to deal with. I'm currently vice chair of the department as well as the head of undergraduate advising. My background in the department and in my professional life is as a vertebrate paleontologist. I study bone growth in dinosaurs and pathology in the fossil record, or as one of my former grad students called it, dinosaur owies. My background is kind of split between geology and biology, and the anatomy side on the bio side as well as the geo side, because paleontology is very interdisciplinary. So that's basically me. I teach our gen ed course in earth history. I also teach 2 paleontology courses in the department, one invertebrate, one vertebrate, and I meet a lot of the students because of my advising work. So looking forward to meeting you.
DT?
Hi, everyone. Thank you very much for coming to join us this evening to learn more about our programs. My name is Dr. Dennis Terry, formally, but I don't go by that. I go by DT. And my main goal as a geologist is to try to use what you see preserved in the strata behind me in my virtual background in order to understand paleo environments and paleoclimates. I'm very much interested in how the planet has changed through geological time. And so I use a lot of different tools within the geologist toolkit, sometimes geochemistry, sometimes looking at the strata that you see behind you. And every once in a while, Dr. Allison and myself will play with some of the fossil critters that are preserved in these strata because they also have clues to what the planet was like millions of years ago. And so I teach a combination of undergraduate and graduate classes. And then should you decide that you want to come to Temple and become part of our geology and environmental science family, I am probably one of the first people you are going to see in the classroom. And so I'll look forward to meeting you. Other things about myself, most of my work is out west in the Badlands of the Dakotas, the Nebraska. Maybe some of you had the chance to go out there on a family vacation. If not, should you join our department, your first assignment will be to go to the Badlands of the Dakotas in Nebraska and report on me what you see. Otherwise, something which for myself, and I think I can say this for any member of our department that is either in this meeting or that you see on our webpage, if you have any questions whatsoever, send us an email. And if we don't have the information or the answer that you need, we know where to find it, because we're here to help with the transition as should you decide to come into Temple and join our program. And as Nick was saying, we are really one big happy family. And it's not a lie, geology students and environmental students, we are the happiest ones on campus because we get to play with rocks. What's better than that? So I'll shut up, and whoever's next.
Sujith.
Hey everyone. My name is Sujit Ravi, and I'm an associate professor in the department. So I'm also the director of the environmental science program. So welcome everyone. So my background is in hydrology, or more in eco hydrology. So I look at impacts of humans on water cycle, and mostly in the context of food and energy production. So I do experiments and data analysis and lab experiments and modeling to kind of address a lot of these research questions. So I do a lot of international work. So a lot of my work in the past 5 years has been in Inner Mongolia or Namibia and Western US, or in Indonesia recently. So yeah, welcome everyone. So thanks. Yeah.
Steve.
Hello, everyone. My name's Steve Peterson. I am the token alumni from the department today. I did my undergrad at Temple. I got a job at Temple. I loved it so much. Then I got my master's at Temple. So I can't tell you how much I appreciate Temple and what it's done for me in my career. So I've worked in the education sector. I've worked in the private sector. And now I work in the government sector for the state of Delaware. So again, if you have any questions that, you're maybe a little leery about asking some of the professors, feel free to reach out and ask me. You can put it in the chat, or I can give you my email address. I still have my temple.edu email address. So that just goes to show you how much I like Temple. So welcome. And I can't wait to see you on campus.
And Hannah, our most important panel participant.
Wow, thank you. I'm Hannah. I am a current undergrad student. I am a senior, and I'm a dual major in both geology and environmental science. And I'm also getting a certificate through the department called the Environmental Professional Training, I think. And I also do student advising and advocacy through the department. So I'm also on campus right now. And so, yeah, I'm the undergrad student here.
All right. So as you've heard enough from me, but I'll just mention that I teach a course on data analysis and visualization, which most of the environmental science students and geology students take. I also teach structural geology focused on the mechanics in the earth. I'm particularly interested in hazards related to tectonics, and a lot of my work is in geothermal energy development as a sustainable baseload energy resource. And in the past, I've also taught a class similar to one of the ones Sujit Ravi teaches on energy resources and limitations and impacts under sustainability concepts. What I'm going to do now is I would very much love the participants to give some bit of an introduction of themselves and where they're coming from, and perhaps where their interests lie, and we can structure our conversation around things that interest you, either about the program or about the things you think you might be interested in studying. And of course, if you haven't decided those things very narrowly yet, that's fine too.
Hi, my name is Tom Hurst. I go to Roman Catholic High School in Philadelphia, and I'm interested in sustainability and like hydrology. Mr. Ravi, can you explain some kind of like experiments you've done or examples?
Yeah, sure. So a lot of my current research is looking at impacts of large-scale energy development, so mostly renewables. So as you know, we're expanding our renewable energy production because of the impacts of climate and all these things, right? So I'm kind of looking at what happens if we have this rapid expansion of renewable technologies like wind or biofuels or solar. What kind of impacts that can have on the environment, like on land use and water use and things like that. So so kind of the important question is we're trying to answer this question of are renewables really sustainable, right? Because people kind of perceive them to be the same, like renewables and sustainable, but they're like what? So what we are seeing is that they're different. So renewable doesn't mean that it's sustainable. These are two different things, and we probably need to treat them as two important things when we look at our choices for fuels, right? So, so kind of the experiments we do are right now. One of my grad students is working in looking at the impacts of large solar power plants and how they're taking over, what kind of impacts they have on agricultural lands in different parts of the world. And if you're leasing out your land for like large solar power plants, like what's happening to the soil and water in that system, right? Is it degrading that ecosystem, or can you actually change that back to an agricultural land in the future? So those kind of questions. Then we are also looking at how to introduce renewable energy to areas which don't have any electricity access. Like, so that's something that we are doing in Indonesia, where it's very isolated population and geographically isolated like island system. So we're looking at what kind of configurations of renewable energy like solar are going to be successful there. So we're looking at both the science aspects and also the policy aspect, like how it's economically or like socially successful in that regions. So we do actually real field experiments by setting up like sensors to measure environmental parameters in the system, or we do like and we gather the data remotely and use some analysis to answer the questions. And we also try to do like modeling, like mathematical modeling, to predict what will be the future scenarios. Like, if this kind of expansion continues for like 50 years or something, what will be the impacts at that scale, right? So that's some of the projects I'm currently working on.
All right, thank you.
I'll mention with Sujit's work that it's an interesting marriage of both the science part and this economic feasibility element, which is really critical to making sustainable approaches actually viable. That's included in his work. Can we get an introduction from one of the other participants?
Yeah, I can go next. I'm Ryan. I go to school at Wells High School in Washington, D.C. And right now I find myself really interested in climate change and renewable energy.
Yeah. I'm in this call. Okay. And then I go to tutoring. Sorry about that.
No worries at all. Maybe while Lauren's getting sorted out, Abby or Genevieve, would you introduce yourselves?
Hi, I'm Abby. I go to Colombo, and I'm not really sure what I want to do specifically, but I know that I want to do something to help save the environment and clean the oceans.
Well, we can definitely offer some interesting looks at there. I know both Bojang and Sujit, for instance, have been looking at things like what's happening to microplastics, which are an interesting issue in the oceans. And we do have specialist Ilya Vojnovic on coastal processes and related sea level rise and impacts on with storms that also bear on the interaction between the ocean and the and communities along the coast, since roughly 50% of all people actually live along the coastline or within 100 miles of it. Genevieve, are you available to give an intro?
Yeah, my name is Genevieve. I'm here in high school and I go to Hallahan High School, and I'm into climate change and like hydrology. Yeah, I can't say it
right. Yeah,
you got it.
Science is like
right.
Lots of terms.
The water, right?
Yeah.
And Lauren, are you available?
Hi, yes. Sorry about that.
Not at all. Go ahead.
Hi, I'm Lauren. I go to West Potomac High School in Virginia, and I'm interested in like environmental science, biology, and also like some aspects of sustainable agriculture and like the future of like food and stuff.
Excellent. Yeah, so that clearly nicely overlaps with some of the focus in the department, and all of you have expressed interest that nicely overlap either with the general earth science program or with the new concentrations we'll be introducing as you join Temple.
Can I jump in for 1 second, Nick?
Yeah.
Yeah, one thing I wanted to say is particularly a lot of what I can talk. What you all have been talking about dovetails really nicely with what's going on in our department. But I want to make the point from the beginning that this is my advisor hat, that even though some of you seem to have more specific interests already, others might just be more, I'm interested in overall in the earth sciences, in the environment. And by no means do you have to know exactly where you want to specialize coming in. And I think Hannah can speak to this as well, but the initial set of courses, both for all of the new concentrations in the environmental science major, as well as for the beginning of both the environmental science major and the geology major, it's a common set of background courses. So if you're not sure exactly where you want to specialize to start with, that's completely fine. And then as things get going, we help you to declare the specific major and the concentration moving forward.
All right, so I think, keep in mind, I think that's an excellent point that you start out with a sort of a broad funnel, and then you kind of get to choose the direction that you'll exit that funnel in. At this point, though, I think what might be really helpful is if you have any sort of specific questions or even general questions, and that we could answer, or different perspectives. You have faculty here, you have alumni here, you have a current student here. We can address things that you might be curious about, either about Temple or about the department or about your course of study. Ryan, do you have a question to ask?
Yeah, this is for Hannah. I actually just wanted to know, like, just like, what are your classes like in your life, just like at Temple?
Sure. Pretty much your freshman year, it might be more intro classes, kind of like what Nick was saying. And then now in my senior year, I'm in pretty specific classes on electives, what I wanted to take, but I find a good balance between going to classes, and I have a lot of time to do extracurriculars or do work with the department. If you have any more specific questions about like workload or what my courses look like.
Yeah, like that. Like
Okay, yeah.
Workload and stuff. Yeah, what's that like?
Yeah, it's definitely, you put in the work that you want to see get out of the classes. And I think it's really important to engage. And so spending a lot more time than probably you did in high school studying and putting a lot more effort into just doing homework than high school. But I think you get a lot more out of it. You get a lot more out of your professors. The EES department specifically, I find that the class to student ratio is really, it works really well. I'm able to engage with the professor, but there's also other students I can talk to and make groups with. I hope that kind of gets there. It's a pretty, college is more intense than high school, but you get more out of it, kind of thing.
That's cool. Thank you.
I'll comment briefly that you'll see courses within the department often are a lecture and a lab combination. There are some courses that just are straight, 3 hours a week, 2 or 3 meetings a week, but often there's an extra sort of practical aspect that might take you to the field or into a lab. Some of those courses are actually taught flipped, so that you have sort of a lecture that you view at your own pace, maybe segmented, and then you come into the class to work on it with the student. That's actually the trajectory for data visualization and analysis, for instance. And then I think the other point I want to make is I often find Hannah, especially pre-COVID, just hanging out around the department. We have tables set up, there's a communal area, and students will often just work there with the support of their peers. And as often as not, just wander into the faculty office who's there during the day, or we're often there late at night, and ask questions and have conversations. And so I think you'll find that it's more collegial. You'll notice we are all going by first names. because I think college is a transition towards independence and working with people as colleagues, and not just as a one-way dissemination of information. And so I think you'll find that courses are more of a collegial endeavor, an investigation together, where we share some information and then you get to practice it and then we talk about it and work together. Tom, do you have a question you'd like to pose?
Yeah, I'd like to just kind of like what are your plans for after graduating?
Great question. So I don't want to go straight into grad school, but I do want to go to grad school at some point. So I'm probably going to do a service program, AmeriCorps. And I feel like there's been a lot of help in the department kind of figuring out what I want to specialize in. Like there's a lot of variety in what the professors' backgrounds and research are in, but I haven't found that yet. So hopefully I will be inspired at some point. A good question.
Thank you.
What about anyone else with questions?
Go ahead, Tom.
How many students are currently enrolled in the program?
So included, actually, Allison might be the person who can best quote the number, but we typically, in terms of majors within environmental science and geology, we typically range from between 100 and 150 majors, often down around 120. The environmental science program is 2/3 to 3/4 of the total number of students, typically. We have 15 faculty in the earth science department who you would have regular contact with, as well as their graduate students and various adjuncts who often come in to teach specific classes. And then there are also the biology professors and then chemistry and other departments that will also represent some of the courses that you might want to take. And you would have access to all of them as well.
And just to jump on that, there's, 100 or so students. Those are freshmen, sophomores, juniors, seniors, all combined. So it's not like you'd be coming in with 100 other freshmen, just to give it a little perspective. Sometimes when you say there's 120, you're like, oh.
So the majors courses are typically 10 to 20 students.
Yeah, it's
and
pretty
even
awesome.
Physical geology, which tends to have a somewhat larger lecture, is divided up into sections that meet as separate labs, each of which will be 10 to 20 students with an instructor as you do the practical parts of the work.
All right, thank you.
You're welcome.
I have
Tom.
one more question. What kind of internship opportunities would there be? Like, I guess after graduating or during school?
So we don't have within the department a formal internship program, although the College of Science and Technology does provide a pipeline for internships. We have focused more on research opportunities, which can go over the summer and can be funded through the URP program as that mechanism. We also, when internships do become available or job opportunities in general, we use that EES Connections website to actually push that information out. The other mechanism that Temple offers, in addition to its formal, CST program, is the Owl to Owl program, which can be a great way of making a connection that leads to an internship using the network of an alumni.
All right, thank you.
I just want to jump on that as well. We Temple EES has a very strong alumni network throughout the environmental consulting world within Southeast Pennsylvania and adjacent states, so Delaware, New Jersey, a little bit into Maryland. We are constantly getting we meaning the faculty, getting phone calls, emails from alums at various firms letting us know, hey, we've got an internship that's open, or we have a job that's going to be opening up. Please, recommend your good students, because they've been through the program. They know what our program is doing. And we have a very solid connection and a solid pipeline to the local geoscience community in terms of employment opportunities.
And we also have a few other mechanisms that can help make those connections. You know, I manage a LinkedIn network. Primarily what that does is you would join my network and you would get suggestions from other Temple alums from our department. DT has maintained a Facebook group through time that has had people posting, you know, things as explicit as I'm leaving my job in X. It's about to be posted. Let me know if I need to put in a good word for you. That sort of thing has happened. I had at a geothermal company in Reno, my former student got an internship there because a student from back in 2011, Matt Sophie, recommended he get the internship, who was another Temple alum, and then they handed off, and Matt went off to another career in a different energy company, and Drew joined that company and then transitioned into a full career there.
Yeah, Matt's now living the life in New Zealand.
Yeah, he's traveled all over the world. Are there other questions, Lauren, Abby, Genevieve, that you would like to pose? Otherwise, we could have a more open, informal discussion as well.
I'm curious about the resources for career, like figuring out your career options, as well as whether what your recommendations are versus like staying more broad in the earth sciences in your undergraduate and then getting more specific during your graduate studies. Because I guess I'm a little conflicted whether I should like the advice that I've been given.
Advice as to when you should specialize?
Yeah, I think like I've just heard that it's like better to stay broad in your undergraduate and try and like figure out what you're really into. So yeah.
All right. I jumped on you, Steve. I'm sorry. I'm gonna let you take that.
No, that's fine. I agree with that sentiment, and part of that answer is a little tricky. Like, I'm from Delaware County, Pennsylvania, which is just south of Philadelphia. I've grew up here. I live and breathe Philadelphia sports and things like that. So leaving the area was never even a thought. So but if you wanted to go abroad, then you could specialize in something that is more, like if you wanted to do oil and gas, like maybe go to Texas or Saudi Arabia or something like that. But in the area, there's so many opportunities for an environmental scientist just in this region, if you're looking to stay in this region. And obviously that goes for every part of the planet. But so starting broad, and then as Hannah said it as well, like, trying to narrow it down can be daunting because it's all awesome. They're all awesome topics. They're all, super interesting subjects. I would have loved to done a PhD in any one of these realms of science. So just knowing that ahead of time, I agree with some of the advice you've been given. Start broad, keep your options open. And honestly, sometimes it's a connection with the professor. We have so many great professors in this department, and I've made little connections with each and every one of them about, what they're doing, how, specifically helping in the lab or helping with research or, presenting at national conferences. When I was an undergrad and graduate, I must have went to probably 10 professional conferences, and I even chaired a session at a professional conference as an undergrad, which is really, really cool. So I agree. Start broad, and then let the science lead you where it will lead you. Is my advice anyway.
I'll make a brief comment in case someone else wants to jump on, but the either program that you choose, whether it's geology or environmental science, and then one of the concentrations, it's going to give you a broad foundation in science. You're going to have core math, core chemistry courses, great applied courses in the department. that really set you up to have choice when you graduate, where you start to think about what might seem like specialization is you start thinking about how am I going to use my electives? Am I going to emphasize a math? Am I going to emphasize a remote sensing? Am I going to emphasize some other aspect like GIS that helps me develop a skill that I'll bring to something like that? And that still leaves you lots of room. You know, it is graduate school or the career that comes after undergrad. You have a lot of choices, and we will make sure that you have a broad enough foundation to not really eliminate a lot of choice then. I think it really is that next step that comes down to specialization.
And that's
go ahead.
And that's where the advising part of it comes in as well. At Temple, advising is sort of two-pronged. There are advisors within the college that will take care of your requirements for graduation and keeping you on track there. But there's a suite of advisors within the department. Myself, Dr. Ravi, Dr. Bunievich, Dr. Grandstaff, there's our student advisor, and we will help you through every step of this journey to try to figure out, well, where are your interests lying? If you think they might be going this way, what's a good course sequence to do? And you're not limited to just the official department advisors either. You start doing research with a grad student, you'd start to develop a rapport with the faculty member. You can, talk to them about what they would suggest if you're liking that subfield. So our entire faculty, as well as our graduate students and our upper level undergraduate students, are invested in mentoring students that are working through the program. So as you're trying to figure out how you want to specialize or how much you want to specialize, you're not doing this alone. And everyone I know has been saying we've got the small school feel in the big university opportunity nexus. I've got both sides of this. I did my undergrad at a very small college, and then I did my PhD at a large university. So I've seen both sides of this, and they are, it is spot on. We have the community that I have seen at schools much smaller than us with all of the opportunities of a major research institution. We're not just using this as a talking point for advertising. It really is the culture here. So no matter how you choose to start on the pathway, you are not going to be walking it alone.
Anybody else want to chime in with a thought? I'll offer one specific example of the kind of thing that we're talking about. So back early when I came to Temple, there's a particularly nice example that always makes me feel that I remember too, is a student in my class was interested in seismology, and we don't offer seismology. She thought earthquakes were an amazing issue that she might want to study in grad school, and she just didn't know yet. So coming out of my structural geology course, what we did is we designed an undergraduate project on statistical seismology, and she tried to assess whether there was an enhanced hazard in the geysers geothermal field, which produces about 1.2 gigawatts of electricity for San Francisco. And we reached out to the state rep, and we got data set on what they were doing with pumping, and we got the data set on the earthquakes, and she synthesized that and developed that into an analysis of what kind of impact humans were having on earthquakes. And she took that, and that clinched it for her. And she went on to get a master's degree in Mexico Tech, and then she went on to get a PhD, and she's now a professional seismologist, an award-winning professional seismologist. And again, it was something we didn't quite offer in the department, but she expressed an interest based on that broad work, and then she got a taste of what that would be and what that could be like by interacting with the faculty, and then knew what the next step would be. So let's see if there are any other sort of outstanding questions or thoughts that have come about as we continued the discussion. DT, Sujit, are there additional thoughts you would like to share?
Yes, I have a question for Hannah. So here we go. Sort of an odd way to think about this. What is the best, this is going to sound like a really sheepish question. In your opinion, what's the best part, the most favorite thing about our department that you have experienced or you will take away from us and your experience with us?
All right, I have two things. One of them is probably all of the research opportunities I have been given. I worked with Dr. Allison my first and second year, and it really gave me a lot of insight into research and presenting a poster. And now I'm working with another person in the department, and I'm also working with Dr. Allison again. So all of those opportunities have been incredible. And secondly, I really like, we have a department club that's kind of like a social meetup of everyone studying together. Well, we don't study together, we play games, and we're all like-minded, and we're all environmental scientists or geologists. So we're all passionate about the earth. So we're playing games, but we're talking about conservation, or we're going on hike. Well, not right now, but we'll go on hikes together out in nature. And so it's really awesome having that social aspect in a department about academics, and we're all studying something similar, and it really brings us together. So that's a good question. Thank you.
Now, as the minutes progress here, I want to make sure, I don't know if you've been paying attention to the chat. I did upload a file that provides an overview of the department, a little bit more in depth, some images about each faculty, some information about the programs. I believe the link to the video I also put into the chat in case you want to view it again or show it to anyone in your family. Please make sure you take advantage of those resources if they're of interest to you.
And any of us are more than happy to address any follow-up questions that you might have. All of our email addresses are in those materials and also on the department website. So, please, you think of something later tonight, tomorrow, as you're trying to decide where you want the next phase of your life to go, please feel free to reach out to any of us. We're more than happy to address questions by email, or even to set up one-on-one Zoom meetings. Yep. If you would prefer to do that as well. So it doesn't have to end here if you still have additional questions for us.
And I'll follow on just by pointing out that I have, for instance, arranged next Wednesday a visit with a prospective student, much in the same situation you are. That student will meet with myself as well as Ilya Bojinovic, because they're interested in corals and coastal issues. And so we'll talk about what opportunities there are to pursue those interests at Temple, and also show them the facilities that are available to do the work while they're at Temple. All right, I think we are coming up on the end of the hour. So if there isn't an additional pressing question and no one else from the panel has a point that they'd like to share, we should go ahead and think about wrapping up. So I'll give you a minute or two to collect those thoughts or contribute, but otherwise we'll be progressing towards the end of our meet time.
And from the alumni, thank you all for joining. I love talking about Temple, so just makes me smile. Thanks.
And we just had Bella King join.
Thank you.
Thank you, Abby. Bella,
Thank you, everyone.
Thank you, Tom. I really do appreciate everyone's participation tonight. And again, please don't fail to reach out.
All right, thank you guys.
All right, cheers.
Yep. Hope to see you all in the fall.
Thank you, Genevieve. I do very much hope to see you in the fall, if not sooner.
See you, Nick.
All right, guys, I'm going to stop the recording here.